So hello everyone, welcome back to another particular lecture series of our Reagent Chemistry course, and this is the class 12. And in our previous lectures we are actually discussing about the homogeneous hydrogenation and heterogeneous hydrogenation. So here we are talking about the other hydrogenation reactions, especially some name reaction such as the Rosenmund reaction, Lindler catalyst, and also Raney nickel based reduction. So let us begin with our Rosenmund reaction. So the Rosenmund reaction is nothing but a chemoselective hydrogenation of a acid chloride to aldehyde. Okay, so in our lecture 11, we are actually discussing that ease of hydrogenation by using catalytic hydrogen is easier in acid chloride to aldehyde reduction, and this particular reduction can be done by using the Rosenmund reduction. So what should be the reagent of that particular reaction? The reagent is hydrogen, palladium, and BaSO4. So the reaction is very simple, that this is our acid chloride, and this particular acid chloride in presence of the reagent, that is the hydrogen, palladium, BaSO4, and they got the aldehyde. Now you may think that why it is stop in the aldehyde, it can go to the till the alcohol part, and this is not happening because of the presence of BaSO4. So what happened, that barium sulfate, that BaSO4, is actually reduce the activity of palladium. Here is the heterogeneous catalyst due to its low surface area. So what happened, that in case of any kind of heterogeneous catalysis reactions, what happened, that palladium, it is having the surface because it is a heterogeneous, like it is solid, and the reactant are in the either liquid form or gas form. So what happened, that as adsorption is very important in this type of reaction, and if you know a very little bit about absorption, then you must know that in any kind of surface there is a different active site presence, and depending upon the active site, the physio absorption and chemi absorption takes place. Now what happened, that BaSO4 here is actually acts as a catalyst poison. So what happened, that BaSO4 is already blocked many of the active site of the particular palladium surface, and that's actually decrease the reduction power of palladium in order to prevent over reduction of the aldehyde, and that's why that acid chloride is reduced till the aldehyde part in Rosenmund reaction condition. Otherwise it will reduct till the alcohol. Okay, so this thing you have to remember. Now let us understand the mechanistic pathway of the particular reaction. So this is the palladium BaSO4, so it generate the PdL4. So what happened, that it will do the similar kind of pathway, like first the oxidatively addition takes place of this particular group. Okay, and then this particular hydride transfer takes place, and then reductive elimination takes the typical reaction of the Rosenmund reactions. Okay, so next talking about the Lindler catalyst. Lindler catalyst is a palladium based catalyst supported on calcium carbonate and modified with lead salt. Okay, so the catalyst here is hydrogen, palladium, and calcium carbonate and quinoline, and this particular catalyst has support by this particular CaCO3 and quinoline acts as a reaction poison or catalyst poison here. Okay, and it is selectively hydrogenates alkynes to cis alkene. It is very important that triple bond can be reduced to a cis alkene, and further reduction can possible with this particular Lindler catalyst condition. And the lead component poisons the palladium. There is a quinoline palladium to prevent over the ensure selectivity of the cis isomer, and also it operates under the mild condition, usually in atmospheric pressure and room temperature, and Lindler catalysis is widely used in organic synthesis for preparing cis alkenes. Now let us talk about the Raney nickel. Raney nickel is a highly effective catalyst that is used for the hydrogenation and dehydrogenation reaction in organic synthesis, and also it is if we cover the physical composition of Raney nickel, then it is a nickel aluminium alloy that has been activated by leaching out aluminium, resulting in a highly porous active form of nickel, and in this particular porous part the reaction happens. And Raney nickel is commonly used for the hydrogenation of alkanes, alkyne and carbonyl compounds, and also it is also employed in the dehydration of alcohol and the reduction of nitro compound. And if anyone is interested about the Raney nickel preparation, then they can find it on the YouTube. There is a very good video is there by how to prepare Raney nickel. Now Raney nickel can show different type of reactivity. Interesting type of reactivity. First is the alkene hydrogenation. Like if any alkene is there, then by hydrogenation it got the alkanes. Also, Raney nickel has the capability to do benzene reduction. Now the Raney nickel is capable to do the benzene reduction. That is a very hard thing to do. In the ease of hydrogenation is very hard to benzene to cyclohexane reduction, but Raney nickel is strong enough to reduce the benzene to their corresponding cyclohexanes, and also ketone to alkanes is possible. And this is the nothing but a Mozingo reaction where the ketone is first the thiol has been generated, and after that Raney nickel based treatment the thiol carbon CS bond has been break and to form this type of compound, and CS bond breaking by using Raney nickel can be possible. Also, Raney nickel is also capable to break the C halogen bond and CN bonds also. So it is a very stronger reducing agent, we can say. So with this, we have to end this particular lecture. So thank you for listening.